Hey everyone, welcome back for another weekly live stream review for Intermediate Algebra. Today we're going to be reviewing chapters 2 and 3 to prepare my face-to-face classes for their upcoming exam, and for my online classes this is a great chance to just catch up with where we're at and make sure that you don't have any questions as we move on into our next chapter. Just to remind you guys, you have the ability to chat with me, send me questions via the YouTube chat. If you have a YouTube account, you want to go ahead and log in. And as you can see on the screen, if you're using a mobile device, you want to look at the bottom of the screen for the chat bar, and you'll be able to ask any questions. Hopefully you've had a chance to look at the problems that I've already selected. Those were posted on Blackboard yesterday. They're available under live stream sessions. And then you can ask questions as we're going along, going through these questions. And if you have any other problems from those reviews that I posted that you'd like me to go over, just enter that number in the chat and I'd be happy to go over that question as well. So we're going to go ahead and get started. If you guys haven't already done so, again, please log in to your YouTube or Google account. So that way you can interact and ask questions as we are going along. So our first problem, we're just going to look at a basic linear equation. As we can see, this is a rational equation. To clear the fractions, we want to use the LCD. Our LCD is going to be 18. So we're going to multiply everything in this equation by 18, which means I need to distribute that to all three terms. In my next step, I'm actually going to show that distribution. That allows me to have individual terms that I can simplify one at a time. That way I don't get confused or miss a step. So we've got 18 times x over 2 equals 18 times x over 9 plus 18 times 3 over 2. Simplifying each of these terms, 18 over 2 is 9, 18 over 9 is 2, and 18 over 2 again is 9. So simplifying, 9x equals 2x plus 9 times 3 is 27. We want to combine like terms, so we will subtract 2x from both sides, giving us 7x equals 27. Divide both sides of the equation by 7, and we get our solution x equals 27 over 7. And just a reminder, guys, on the test, you want to make sure that you leave this answer as a simplified improper fraction. Do not write this as a mixed number and do not use a decimal. Thank you. The next question is number 12 from that review. Write the following as an algebraic expression and then simplify. The sum of 3 consecutive even integers if the first integer is y. So just to point out some key words here, we're dealing with just an expression, which means there's not going to be an equal sign and we're not solving this. We're not going to find the value of our variable. We're just setting up an algebraic expression. Now we're also talking about 3 consecutive even integers, and we want the sum of them. So we've got the first number plus the second number plus the third number. Now this just helps me understand what it is they're asking me to set up. Now I need to plug in algebraic expressions for each of these and then simplify. With these particular types of problems, the consecutive integer problems, I find it's easiest to set up a concrete example. So if we're talking about consecutive even integers, an example might be 2, 4, 6. If it had said consecutive odd integers, 1, 3, 5, consecutive integers, 1, 2, 3, this concrete example is going to help me set up my algebraic expressions for each of the terms. They tell me that my first integer is y, so the first number is going to be y. Now my second number, if I look at my example, how did I get from 2 to 4? I added 2 to that. So if my first number is represented by y here, my second number is going to be represented with y plus 2. For the third number, again, looking back at my example over here, I've got to go from 2 to 6. How did I get from 2 to 6? I added 4. Since I started with y, my third number is going to be represented with y plus 4. Now we simplify. We have 3y plus 6, and that is our algebraic expression. Again, no equation or no equal sign in an expression. We're not solving an expression. All we can do is simplify. Number 14, now we're going to solve a problem. A diamond ring is sold for $1,929.60, including tax. If the tax rate where the ring was sold was 7.2%, find the price of the ring before the tax was added. Round your answer to the nearest cent. Now, just like in the last problem, we want to start by just understanding the problem. Every one of us have gone to a store and purchased something that had tax in it. So we pick up a product that we want to buy. We look at the price tag. We know that when we get to the cash register, it's going to be more because of the tax that's added. So we can use this general idea to set up a very basic equation without any variables. We have our original price. That's going to be the price sticker plus the tax. And those things added together end up being what I pay for the product or the price paid or amount. Let's use the word amount, the amount paid. So this equation just sets up what it is they're describing in the context of the problem. Now we can go in and start plugging in algebraic expressions for these different things and known values. For the original price, that's what they're trying to get us to find. They want the price of the ring before tax was added. So that's going to be our unknown x. Now, the tax we know is 7.2%. So we need 7.2% of what? Think about when you go and purchase a t-shirt. To figure out how much you're going to pay, you're going to find the tax or the amount of money that's going to be added to the original. So if I'm trying to find the tax, it's 7.2% of the original price, which is X. And the amount paid is that value that's given, $1,929.60. Now, we're not quite ready to solve yet. We need to fix this guy. 7.2% of X. Now, we've seen problems like this. That word of in these types of problems, these percent problems, translates to multiplication. And we want to make sure we convert that percentage to a decimal. So this is 0.072 times X. So now we have an equation that we want to solve for X. Remember, X represents the original price before tax was added. We want to look at these two terms. They are like terms, even though that decimal in front of the second term looks a little funny. This one has an imaginary 1 in front of it, or not imaginary, an invisible 1 in front of it. So this is 1 plus 0.072, or 1.072x. And that equals $1,929.60. And we can divide both sides by 1.072 to find the value of X, which is $1,800. Now, just thinking about this answer, it makes sense because it should be less than what we ended up paying for it, right? Because we're adding the tax to that. But we can also check this answer. If we know how much it costs and we know the tax rate, we can figure out how much we should be paying. So let's go ahead and try to do that. Let's just check our answer. If our original was $1,800 and I'm adding 7.2%, I've got to add 0.072 times 1,800 to that. And that should give me the amount that I'd have to pay. When I add these two together, I do end up getting $1,929 $929.60. So that answer does check out. And this is a great way to just verify that your answer is in fact correct. With word problems, guys, and this is something that I notice with all levels of students, we want to just kind of memorize an approach based on recognizing similar characteristics from problem to problem. But you really want to take a minute and try to comprehend what it is that word problem is describing. Now, that might mean setting up a real basic equation like the original plus the tax equals the amount paid, or in that I think it's the second problem where we set up the expression where we wanted the sum of the first plus the second plus the third. Those aren't algebraic. Those are just us comprehending what they're describing in the problem. Sometimes it helps to draw a picture, but it is really important, guys, if you want to be able to verify that your answer is reasonable, that you understand exactly what they're describing. That's the reading comprehension, and that comes into play even though we're in a math class. So we want to make sure that we're comprehending the questions in addition to just being able to set up an equation and solving that. The next one is number 17 from that review. A principal of $1,000 or $14,000 is invested into an account paying an annual interest rate of 6%. Find the amount in the account after 15 years if the account is compounded semi-annually. Now, for this problem, we're using the compound interest formula. That is A equals P times 1 plus R over N raised to a power of N times T. Now, if you're looking at the review, you see that that formula is provided in the directions. The directions are going to be exactly the same on the test, which means this particular formula will be provided. However, it doesn't explain what the variables are or what they mean, so you do need to understand how to use that formula, but you do not need to memorize it. So again, going back to the problem, the context, and identifying what values they've given us. They've given us our principal, so we know that this is $14,000. The interest rate is 6%. Since the interest rate is 6%, remember when we substitute a value into the formula, we need to convert it to a decimal, so this is 0.06. The time is 15 years, so that's going to be our T, which I'm going to wait to write that down. And the account is compounded semi-annually. Semi-annually means twice a year, so that's our N. And again, they're trying to have us find the amount, so that's why A is left as an unknown. We can simplify this a little bit before we type it into our calculator. 1 plus 0.06 over 2. This is going to be 1.03. Now, if you can't do this in your head, that's okay. But remember, order of operations, we need to simplify inside the parentheses first. And I did not do this earlier. T is 15. 2 times 15 is 30. Now, when you plug this into your calculator, you can typically just type this whole thing in, but if you feel more comfortable going step by step, which for many people I encourage you to do that, make sure you follow the order of operations. So we want to do the 1.03 raised to a power of 30, and then take that value and multiply it by the 14,000. And when we do that, we get an amount of $33,981. and 67 cents. I'd like to take an opportunity, guys, just to remind you that you can chat with me, send me any questions that you guys may have. If there are other questions or other problems that you'd like me to go over on the review, just go ahead and send me a message. That way I know what you guys need and I can support you the best way possible. All right, moving along in these problems that I had selected. Solving compound inequalities is next. This is number 28 from that review. X plus 5 is less than 6, and negative 5x is less than negative 25. We see two inequalities, so we're going to solve them separately. Subtract 5 from both sides. We get x is less than 1. Over here, we're going to divide both sides by -5. Remember that when we divide by a negative, we need to flip that inequality sign. That's what that little asterisk is for. It's a visual reminder that we need to do something else. So we get x is greater than +5. Now, what's real important here is the word and. What does that mean? They're asking us to find the intersection. Now, in my opinion, the easiest way to find the intersection is to graph these two intervals stacked on top of one another, and what we're looking for is where they overlap. So if I set up a number line, I'm going to mark my two values. That should be the 1 and 5. Now my first interval is x is less than 1. So that's starting at 1 and going to the left. Now my second interval is x is greater than 5. So that's starting at 5 and going to the right. Now, once we have this graphed, we want to go back and revisit the idea that we're looking for the intersection. We need to keep coming back to that because we're going to see similar types of graphs and they yield different answers. Since we're looking for the intersection and I'm looking at these two shaded regions, do they share any values? Is there an intersection? And the answer is no, they don't overlap at all, which means there is no solution for this compound inequality. Had this said or, then we would have had two separate intervals. Okay, so make sure that you distinguish between the and the or when you're solving these two problems, which I believe the next one is going to be an or problem. Oh, nope, not yet. Okay, number 30 from that review, -32 is less than or equal to -4c minus 4, less than -20. So this compound inequality is really saying two things. It's saying -32 is less than or equal to -4c minus 4, and -4c minus 4 is less than -20. Now, if I were to solve these individually, we would take the exact same steps in both because the expression with c is the same. So what we can do, instead of solving two separate ones, we can just solve it as is, remembering that if I do something to one part of the inequality, I have to do it to all parts. So if I'm trying to isolate c, the first thing I want to do is get rid of that -4, and I know I'm going to do that by adding 4. Since I've got three separate sections of this inequality, I'm going to add 4 to all three of them. -32 plus 4 is -28. Less than or equal to -4c. Less than -20 plus 4 is -16. Next, to isolate c, I want to divide by -4. I need to make sure I divide all of the pieces of that inequality by -4. So divide this by -4 and this by -4. And there's my visual cue that says I've got something else to do. That something else is to flip my inequality signs because I divided by a negative. So going ahead and flipping those, this one should just be greater than. We've got our c in the middle. -28 divided by -4 is +7. -16 divided by -4 is +4. Now, this particular inequality is a little bit more difficult to interpret because it seems like it's going backwards. So what we're going to do is flip the entire thing so that we're going from least to greatest. 4 is less than c is less than or equal to 7. And you can check. Do we have c is greater than 4? C is greater than 4? Yep. Do we have c is less than or equal to 7? C is less than or equal to 7? Yep. So we flipped it correctly. We didn't miss any parts. And this is much easier to read and to interpret. To write this in interval notation, we're going to start by graphing. Here's 4 and here's 7. And this inequality says that C is between 4 and 7. So we're looking at the values between them. We are not including positive 4, but we are including 7. So we use a parenthesis when we're not including that value. We use a bracket when we are including that value. And then to write the interval, we basically just pull this right off the number line. 4 to 7. One more reminder regarding the test, guys. In comparison to the review, we have all of our questions are multiple choice for the most part. Please remember that when you show up for the test, you're not going to have any multiple choice questions. So you want to try to avoid using your answers to help you solve a problem, because you won't have that when you get to the test. All right, so our next compound inequality involves OR. 12x minus 8 less than 4x, or negative 2x less than or equal to negative 6. So solving each inequality individually, we'll revisit the OR once we have our two individual inequalities. So we're going to add, that's not what I want to do. Notice, guys, I tried to add 8, and that was just out of instinct because I wanted to get the constant. But this term over here on the right is a 4x, so I can't combine those. So what I really want to do is subtract the 12x. So we have negative 8 is less than 4x minus 12x is negative 8x. Now to solve for x, divide both sides by negative 8. Again, my little visual cue to remind myself to flip the inequality symbol. Negative 8 divided by negative 8 is positive 1. 1 greater than x, we're going to go ahead and flip that. So we have x is less than 1. Over here, divide both sides by negative 2. My visual cue. I know this seems silly, it's an extra step, but it might really help some of us in remembering to flip that inequality symbol. So it might be worth trying. So we have x is greater than or equal to negative 6 divided by negative 2 is positive 3. So we've got x is less than 1, or x is greater than or equal to 3. Now, or is our union. If you are in my face-to-face class, we took a moment to really talk about what union is. And I encouraged you guys all to write the definition for union in your own terms, in your own words, because it's easier to remember things when they're in our own language. So for those of you who are in my online classes, maybe take this as an opportunity to create your own definition for union. Don't just use what I've given you or what was given in a textbook or what you found online. Really write it in your own words. That way you'll have more ownership of that definition. And when you get to the test, that's what you want. You want to look at a question and say, okay, this is what I think when I see the word or, and this is how I'm going to come up with the solution. So I'm going to do the same thing I did with the and. I'm going to graph my two intervals separately. So here's 1, here's 3. This first one is x is less than 1. So that's going to be to the left of 1, excuse me. Sorry guys, I'm just checking where I'm at real quick. Okay, we're good. X is greater than or equal to 3, so that's going to be starting at 3 and going to the right. Now the union, we see we have a similar graph that we had in a few examples prior to this, where we've got two separate shaded regions going in opposite direction. When it was an intersection, there was no solution. For the union, it's everything in either section. So it actually includes both of those. So that red shading would be the formal graph for this solution. To write the interval notation, since we have two separate shaded regions, we're going to have two separate intervals and we're going to join them with the union symbol. My first interval, reading from left to right, begins at negative infinity and goes all the way to 1. Union, my second interval begins at 3, and I'm including that value, and goes all the way to positive infinity. You guys really want to make sure that you're practicing the difference between and or, intersection and union, because that's one thing that can really get us if we haven't practiced. We want to make sure that we know that there is a difference between the two and what that difference is. Okay, number 36, we start graphing now. This example, y equals the absolute value of x plus 4. As we've stated in the videos, we don't have any new techniques on graphing something like absolute value. So our option is to make a table of values, and that's what we're going to do. However, we have discussed absolute value and seen enough examples to know what this graph is going to look like before we even start plotting any points. For an absolute value, we know that the shape is going to end up looking like a V. So when I start making a table of values and start plotting points, if I don't get that shape, then that's a red flag. That red flag could either mean I've made a mistake in evaluating points, or that red flag could just mean that I don't have enough points graphed. But either way, if you know what you're supposed to end up getting, then you can continue to graph or check your work to make sure that you get that. So I'm going to make a table of values, and I'm going to start with my default x values, -2 to 2. When I plug in x equals -2, the absolute value of -2 is 2, plus 4 is 6. Absolute value of -1 is 1, plus 4 is 5. The absolute value of 0 is 0, plus 4 is 4. The absolute value of 1 is 1, plus 4 is 5. The absolute value of 2 is 2, plus 4 is 6. So when I graph these points, -2, 6, -1, 5, 0, 4, 1, 5, 2, 6. We do see that we end up with a shape that's a V. So we are good to go. We'll connect those points, and we are done. If you, let's say, graphed your points and this is what you ended up with, you want to make sure that you continue to add more points to your table. That way you can see that corner in the graph. Put that back up there. Okay, guys, we've got some real quiet viewers out there. If you guys have any questions, please do not hesitate to stop me and ask. This is kind of one of your last opportunities, but certainly a wonderful opportunity for you guys to ask questions and really make sure that you're understanding these concepts. So I encourage you, if you haven't done so, log into your YouTube account. That way you can start interacting and asking questions as we're going. Y equals -3x squared. This is number 37. Just like with the previous example, we don't have any techniques yet for graphing this type of an equation. However, we have seen plenty of them that we know what it's going to look like. These x squared terms, or x squared equations, are going to have a shape, it's like a U. It's called a parabola. So again, when we're making our table of values and we're plotting our points, if we don't get that shape, then we know we either need to check our work, which we should do anyway, but if that's all good, then we just continue plotting more points until we get that nice pretty curve. Again, starting with those default points. I had a student last week ask me why I chose those 5 x values and did we have to choose those x values? And no, you don't. I call them the default x values just because it gives us some negatives, it gives us 0 and a set of positive x values. A lot of times it will give us a pretty good picture, but not always. So you might find that if you start with these 5 x values that you need to plot additional points. You might find that they work just fine. You can pick any points that you want to be honest, but thinking about the grids that are typically provided, just like this one here, you're looking around the origin. So looking at values that are negative, x value of 0 and a couple positive values is usually a good place to start. We have one question about the mastery quizzes. Is today's mastery quiz the last quiz before the test? Pablo, could you just be a little bit more specific? I'm not sure which mastery quiz you're looking at. And also, I'm not sure if you're in my face-to-face class or my online class. So if you can give me a little bit more information, I'd be happy to answer that question. Otherwise, you can look at the calendar. The calendar that I've created for both courses is very detailed and has what's due prior to the exam. While we're waiting on that, let's go ahead and complete this table of values. Remember your order of operation. So I'm going to show that real quick here. When I plug in -2, it's -3 times -2 squared. We need to evaluate the exponent first. -2 times -2 is +4. +4 times -3 is -12. Be very careful. You're not multiplying -3 times -2 and then squaring it. All right, we need to do exponents before multiplication. We plug in -1, -3 times -1 squared. Again, -1 squared is +1 times -3 is -3. Plugging in x equals 0. 0 squared is 0 times -3 is still 0. 1 squared is 1 times -3 is -3. And plugging in +2, 2 squared is 4 times -3, -12. Pablo, for the online classes, Mastery Quiz 4, I don't believe that that's the last quiz before your exam. For the online classes, if you're face-to-face, you can ignore this message. For my online classes, your first exam actually covers chapters 2, 3, and 6. So you guys have another couple of weeks before you take your first exam. But this is a great review for those first 2 chapters as you are finished up with chapter 2 and 3 in the curriculum based on the course calendar. All right, so we have our table of values. We're going to plot these points and see if they give us that nice, pretty U shape that we're hoping to get. When we plug in -2, we got -12, so this graph is not perfect. So I'm going to go ahead and approximate that down here because otherwise I'm going to be off the screen. -1, -3, 0, 0, 1, -3, and then 2, -12, which again, I'm approximating that as being all the way down there. And lo and behold, that's not very pretty. We'll fix that. We have that shape that we were expecting, that parabola, and we see that it opens down. That's okay. That's going to happen sometimes, but we do want that general shape, that shape that's kind of like a curve, like a U. Be very careful, guys. For a parabola, I definitely encourage you guys to try to plot 5 points. That'll make sure that you graph it in a curve. If you only graph 3 points, you might accidentally graph it using a V. I'll show you up here what I'm talking about. If I were to only plot these points, even though it's supposed to be curved, you could very easily connect those points with 2 straight segments, and that would lose some points for you, okay? We need to make sure that if it's supposed to be curved, that it looks curved. Shifting gears, now we're going to start talking about some properties of functions, in particular looking at function notation. Find f of 2 when f of x equals 4x squared plus 4x plus 4. We want to make sure that we understand, what is this asking? Find f of 2. Finding f of 2 just means find the y value when x equals 2. Now, we can ask this question given an equation like so, and then we can also do this from a graph. So I believe there are questions in the review if they're not in this in this set of examples that you can take a look at, but just knowing that when the directions say find f of 2, they're asking for the y value. But to evaluate this algebraically, f of 2, we're just going to substitute 2 in for every value of x. 4 times 2 squared plus 4 times 2 plus 4. And I'm going to do some mental math while following my order of operations to try to simplify this before I reach for my calculator, because if I type it into my calculator incorrectly, then it's going to give me the wrong answer, and we're not going to know any different if it's supposed to be that or not. So order of operations, 2 squared is 4, so 4 times 4. 4 times 2 is 8 plus 4, 16 plus 8 plus 4. So at this point, I've done a lot of the real basic, real easy mental math. And here, maybe I'll go ahead and grab my calculator, and I'm just adding 3 integers. So that's pretty easy, straightforward. I don't have any issues with that. When we combine these, we get 28. So f of 2 equals 28. The amount of water in a leaky bucket is given by the function f of t equals 128 minus 3t, where f of t is the number of ounces and t is in minutes. Find the amount of water left in the bucket after 6 minutes. So we're trying to find the amount. So we're looking for f of t, we're looking for the y value after 6 minutes. So that's my t. So I'm trying to find f of 6. Plugging in 6 everywhere we see a t. 128 minus 3 times 6 is 18. And then 128 minus 18 is 110. And again, this is the y value, so the units we would use is ounces. Now, whether or not you actually write the units down, it is important to consider them because we can use that as a way to verify that our answer is reasonable. In this particular example, had I been looking for a value of time and I solve my equation and I get time is negative, well, if I think about the number representing a number of minutes, I can't have negative minutes. So again, using and considering these units will help check if your answer is even reasonable based on the context of the problem. Graph the equation negative x plus 8y equals 48. Hopefully we recognize that this is linear, and since it's linear, we know that the graph is going to be a straight line. Now, unlike the absolute value and the quadratic, which was the x squared equations that we graphed previously, we actually do have several techniques to graphing a linear equation. We can make a table of values like we did before. We can find our x and our y intercepts by plugging in 0 for x or 0 for y. We can also convert this to slope-intercept form and use the y-intercept and the slope to find points. Now, my preference is slope-intercept form. However, I really don't care. I want to make sure that you guys know how to graph a line, and if you have a technique that you prefer, then please feel free to use that. But as a rule of thumb, if you're moving on to another class like college algebra and beyond, slope-intercept form is probably the go-to technique for graphing a linear equation. So we're going to demonstrate that here right now. To write this in slope-intercept form, we want to isolate y, so I'm going to start by adding x to both sides. So we have 8y equals x plus 48. And then I'm going to divide everything by 8. So we have y equals, the slope is going to be 1 over 8. We have a constant of 1 in front of x. And then 48 divided by 8 is positive 6. So this tells me that my y-intercept is 6, and my slope is 1 over 8. So when I graph this, I'm going to start at my y-intercept at positive 6, which this grid isn't fantastic either for this problem. And my slope is 1 over 8, which means I'm going to go up 1 to the right 8. So visualizing this, I'm going to go up 1 and then over 1, 2, 3, 4, 5, 6, 7, 8. And that would give me 2 points. Now, hopefully you guys can see that. It's right at the very top right-hand corner. If I wanted to plot additional points, I can plot points in the other direction. Notice I've got all this space over here on the left. So to graph going the other direction, we're just going to use the opposite of both. So I can go down 1 to the left 8. Now, watch when I do that. It's going to keep all of my points again in line. So if I go down 1 over 1, 2, 3, 4, 5, 6, 7, 8. Now all 3 points have still remained collinear. Not a super straight line, but it's the best I can do right now. If you guys are graphing and you start seeing the graph go from here and then go back up this way, obviously that's not correct. It could go this way and then that way. Again, knowing what your graph is supposed to look like is going to help you, have those red flags that say I've done something wrong. Because again, this is a linear equation, so my graph should be a straight line, or will be a straight line. Not should be, it will be. Number 57 from that review, find the equation of a line that passes through the points 10, negative 58, and negative 3, 7. Write your answer in function notation. So to write the equation of a line, we need 2 things. We need slope and we need any point. Now we're given 2 points, so that second requirement is satisfied. But what about slope? We're not given the slope explicitly, so we need to find the slope. And we're going to use the slope formula to do that. My slope formula is y2 minus y1 over x2 minus x1. So if I plug in those 2 ordered pairs, y2 is 7 minus y1 is negative 58 divided by x2 is negative 3 minus x1 is 10. Now, if you had chosen the other points as x1, y1, x2, y2, it won't make any difference when you're finding the slope, okay? Simplifying the numerator and the denominator, 7 minus negative 58 is the same as 7 plus 58, which is 65. Yeah, 65. And then negative 3 minus 10 is negative 13. And we can check if this simplifies. You can grab your calculator. It might simplify very nicely, which in fact it does. 65 divided by negative 13 is negative 5. And then obviously we have any point. We can either use 10, negative 58 or negative 3, 7. I'm going to use negative 3, 7 just because it's smaller values. So now that we have both of the requirements, we have our slope, we have a point. Now we either use slope-intercept form or point-slope form to write the equation of a line. I'm going to show you guys both techniques just so that you can see them both. If you haven't, again, it's up to you, whatever your preference is on how you come up with the equation of a line. I don't care. So I'm first going to show you point-slope form. So that's y minus y1 equals m times x minus x1. We're going to substitute negative 3 and 7 for x1, y1, and negative 5 for m. So we have y minus 7 equals negative 5 times x minus negative 3. X minus negative 3 is the same as x plus 3. Next, we're going to distribute the negative 5. So we have y minus 7 equals negative 5x minus 15. And then to isolate y, we're going to add 7 to both sides. So we have y equals negative 5x, negative 15 plus 7 is negative 8. Now, the question asks for you to write your answer in function notation. This is a very clear direction, but you need to know what it means because as is, the answer is not correct. To write it in function notation, it's a real easy change. We're just going to replace y with f of x. So there's the equation of our line that passes through those 2 points. Now I'm going to show you how we can find the same equation using slope-intercept form. So slope-intercept form, that's y equals mx plus b. Now we already have our value of m, so we can substitute that in, negative 5x plus b. And now to complete this equation, we need to solve for b. We've got our point, negative 3, 7, which we're going to now substitute in for x and y, respectively. So 7 equals negative 5 times negative 3 plus b. Negative 5 times negative 3 is positive 15. We're going to subtract 15 from both sides. 7 minus 15 is negative 8, and that's the value of b. Now, right away, I'm sure some of you are thinking, man, that's so much easier and so much faster. The trick is remembering to take that value of b and plugging it back in. So we have y equals negative 5x minus 8. And then to write it in function notation, simply replacing y with f of x. So 2 techniques, I wouldn't say one is necessarily easier than the other. Some of us are just accustomed to using point slope form. If that's what you're used to and that's what you're good at, keep with it. It works just fine. But for those of us who are still trying to learn this and maybe we think that slope-intercept form is going to be a better option for us, then go with that. If you want to switch every single time, that's cool too. This is really an option for you, and we want you to use what works best. Okay, so I didn't get any questions or requests for problems, so hopefully we're feeling real confident in chapters 2 and 3. As you know, you can always email me if you have any questions from those reviews, and good luck studying. We'll see you guys next time. Have a great day.